You've heard that nothing can travel faster than the speed of light. But here's what nobody tells you. The speed of light isn't actually about light. It's about the fundamental structure of reality itself. And if it were even slightly different, you and I wouldn't exist to have this conversation. Most people think the speed of light is just how fast photons move. That's like thinking the speed limit on a highway exists because of cars. But the speed limit exists because of the highway itself. In our universe, space and time have a built-in speed limit. And once you understand why, everything changes. Let's start with the number itself because it's almost impossible to wrap your head around. Light travels at 299,792,458 meters per second, about 186,000 miles per second. Here's what that actually means. If you could travel at light speed, you'd circle the entire Earth 7.5 times in 1 second. You'd reach the Moon in 1.3 seconds. The Sun, an 8-minute trip. But here's the thing that blew my mind when I first learned it. When physicists talk about the speed of light, they're usually not talking about light at all. They're talking about something way more fundamental, what we should really call the cosmic speed limit. Light just happens to travel at this speed because photons have no mass. But gravitational waves, they travel at this exact same speed. So do gluons, the particles that glue quarks together inside every proton and neutron in your body. Think of it like this. Imagine the universe has a maximum refresh rate like your computer monitor. No information, no cause and effect, nothing can propagate faster than this cosmic speed limit. Light travels at this speed not because there's something magical about light, but because there's something fundamental about the universe itself. This speed, physicists call it c, is literally built into the fabric of space and time. It's not just a speed, it's the rate at which cause and effect can spread through reality. When you flip a light switch, the electrical signal can't travel faster than c. When the sun explodes, which it won't, but if it did, we wouldn't know about it for 8 minutes. That's not because light is slow, it's because reality itself has a speed limit. Now here's where it gets genuinely weird, and this is what broke physics in the early 1900s. The speed of light is the same for everyone, no matter how fast they're moving. This goes against every intuition you have about speed. You know how speeds normally work, right? You're standing by a highway, car passes at 60 mph. Someone in that car throws a baseball forward at 30 mph. You see the baseball moving at 90 mph, 60 plus 30. Makes perfect sense. But light doesn't work this way. At all. If that same car had a laser pointer instead of a baseball and someone shined it forward, you'd measure the light beam at exactly the speed of light. Not the speed of light plus 60 amperes, just the speed of light. The person in the car would also measure it at exactly the speed of light. Someone in a rocket ship going half the speed of light would still measure that same laser beam at exactly the speed of light. This sounds impossible. But we've tested it thousands of times. The speed of light is constant for everyone, no matter how they're moving. Here's why this breaks everything. If light speed is constant, but speeds normally add up, then something else has to bend. That something is space and time themselves. Let me give you a concrete example. You and your friend both shine laser pointers at a wall that's exactly 1 light second away. You're standing still. Your friend's in a spaceship racing toward the wall at half light speed. Old physics says your friend's laser should hit the wall first. It's got a head start, right? But both lasers hit at exactly the same time. Both travel at exactly light speed. How's that possible? Here's the mind-bending answer. Time runs slower for your friend. From your perspective, their clock literally ticks more slowly. Space also shrinks for them. Distances actually compress in their direction of motion. This isn't an illusion. This isn't a measurement error. Space and time themselves stretch and squeeze to keep light speed constant for everyone. This is why the speed of light isn't really about light. It's about how space and time are woven together. Einstein showed that they're one fabric called spacetime, and light speed is basically the conversion rate between space and time in this fabric. But here's where it gets even stranger. While nothing with mass can travel at light speed, there are things that can appear to move faster than light. And this doesn't break any rules. Picture this. You're holding a laser pointer, sweeping it across the moon's surface. Move it fast enough, and that dot of light can zip across the moon faster than light speed. But nothing's actually traveling faster than light. The photons are still crawling from Earth to Moon at normal light speed. What's moving faster is just where those photons happen to hit. No information or energy actually travels faster than light. Same thing with shadows. Wave your hand to cast a shadow on a distant wall, and that shadow can move faster than light. But again, nothing physical is moving that fast, just the location where light gets blocked. The real speed limit applies to information, energy, and anything with mass. And here's why nothing with mass can reach light speed. As you approach light speed, something extraordinary happens to your energy. You know Einstein's E equals mc2? That's actually the simplified version. The full equation is E2 and core mc2 2 plus p alpha 2, where p is momentum. As you speed up, your momentum increases, so your total energy increases. As you approach light speed, your momentum approaches infinity, which means your energy approaches infinity. To push any object with mass to light speed would take infinite energy. That's not a tech problem, that's reality saying nope. This creates fascinating consequences. Particles in the Large Hadron Collider routinely hit 99.99999% of light speed, but that last 1%? Impossible. They'd need infinite energy to cross that final threshold. So why should you care? Because light speed being exactly what it is makes your existence possible. Every photon hitting your eyes right now traveled at light speed to reach you. Light from your screen took nanoseconds. Sunlight took 8 minutes. Light from the nearest star took 4.2 years. When you see the Andromeda Galaxy, the most distant thing visible to your naked eye, you're seeing light that left 2.5 million years ago when early humans were learning to use stone tools. This means when you look up at night, you're literally looking back in time. You're seeing a cosmic history museum with objects at different distances, showing you what the universe looked like at different moments. Light speed creates a natural time machine built into the act of seeing. But more fundamentally, if light speed were different, the forces that hold atoms together would be different too. Light speed is deeply connected to electromagnetic forces. The ones keeping electrons orbiting atomic nuclei. Change light speed significantly, and you disrupt the delicate balance that lets atoms exist as we know them. The precise reactions powering your cells, letting DNA replicate, making water behave like water, all of this depends on physics constants, including light speed being in very narrow ranges. Light speed also sets the ultimate limit for information travel anywhere in the universe, including in your brain. Your neurons are much slower than light speed, but they still can't exceed this cosmic limit. When you touch something hot and yank your hand back, that reaction time is bounded by fundamental physics. Even your phone's GPS depends on light speed. GPS satellites have to account for time running slightly slower in Earth's gravity and slightly faster at their orbital speed. Without understanding how light speed relates to space and time, GPS would be off by miles within hours. And here's something that might keep you up tonight. Light speed determines the size of your observable universe. Because light takes time to travel, and the universe is only about 14 billion years old, there's a limit to how far we can see. Light from beyond about 46 billion light-years away hasn't had time to reach us yet. Light speed creates a horizon we literally cannot see past, no matter how good our telescopes get. So when someone tells you nothing travels faster than light speed, they're really telling you something profound about reality's architecture. Light speed isn't a limit imposed on things moving through space. It's the rate at which space and time themselves can carry information and cause an effect. It's the cosmic refresh rate of reality, the fundamental tick of the universe's clock. Light travels at this speed not because photons are special, but because they're massless and therefore hit the maximum speed anything can travel in our universe. Other massless particles hit this same speed because it's not about the particles, it's about the universe itself. And this speed being exactly what it is rather than faster or slower is why you exist. It's why atoms stay stable, why chemistry works, why information flows through your brain, and why you can look up and see billions of years of cosmic history written in light. Light speed isn't just a number in a physics book, it's the fundamental constant that makes everything else possible.